Hey guys, just an introduction. This is the second part of the machine learning course, basic one. And the previous class, I gave you a theoretical introduction. So this is the practical part. Could you access the course, the folder?
The script is ml for biologist.r, right?
No, it's in
Oh,
this SCR folder. And I think
okay,
it's RF training, lab training.
okay,
Okay.
okay.
As I said in the last class, I decided to show you the random forest because it's very popular in our field and it's good. The random forest use random data set, so do it automatically, randomize the data and evaluate these using different several decision trees. Really cool for us using the biological data. And the most interesting part of using random forest is the possibility to evaluate the importance of each one of the features. In our case, can be genes, proteins, and so on. So we can evaluate the importance of the features in the model, and this can enable us to select the best ones for our proposal. Everyone's okay with the script? We can start? Can we?
Yes.
Okay, perfect. So, as I said, this is the source. It's from Towards Data Science. It's an interesting blog for biologists and for data scientists as well. And this is the link for the folder for who is not in there yet. Just to start, let's remove all the things from the environment and let libraries is random forest, parrot, a dot in here, tools, ggplot, ggtem just to make some plots, and data explorer to create a report with our data. This is really nice for when we start with a new data set when we have no idea how about the data. So this is really nice and it's really useful. So this is my working director, and this is the data. Just to see the data very fast, like this. This is data that you can find in the folder as well in the data in the website that I gave the link for you guys. So this is just I choose this kind of can
But
talk.
can you explain this data? What means those numbers?
I'm going to explain a bit about these data, but it's not important for us. It's just a way to show that it's important to have numerical data, how to explore your data, and how to prepare for machine learning. But it's not relevant for us. It's not a biological data, classic biological data as you use in our lab, and it's not. It's just a way to train.
Okay.
Um,
But I'm
but
going to explain a bit.
but we have for for we to use machine learning. It's basically we have the biological data like genes and their fold change. I don't know what exactly it's, but
Uh,
is this resemble with this
Yeah,
data?
you can use for chain data and
Mhm,
expression data as well. There's no
mhm.
problem, but you have to make sure that you can compare the classes in appropriate way.
So our data, biological data resembles to this data what you are showing, right?
Yeah, this is not exactly biological data, but it's more like it's a biological.
It's
It's like a
similar.
clinical data.
Okay.
But you
It's
can
yeah.
use the same for expression data.
Uh-huh. Okay. Right. Right.
Uh, but remember that we need to keep attention in the type of data because if
Uh-huh.
the values are different, the model can understand that the higher values of
Mm-hmm.
features are more important than the others, but this is just a normalization issue. It's not based on the importance of the feature. I said this in the previous class, but I know that some of you were not in here in that moment. So
Okay.
keeping in mind that it's important to know the types of features and clean the features in the best way as possible.
Okay. Thank you.
Okay.
Okay.
So just to show you the data again, it's like this. We have the numerical features, and after the guys put the number, the name of the columns in here. So they are all numerical data, but they have different scales. And here, just to put the name, age, sex, CP, joy, FBS. To be honest, some of them I have no idea what's about. It's just to show you how is the process, to you be able to do this with your own data. But if you have any doubts with your own data, guys, you can ask me any question. I know that's difficult, this part of process the data to create a new machine learning model. But if you have any doubts, just keep in touch with me, okay? And this is a bit, this is to create the report using the library Data Explorer. Just to we see about our data without spend a lot of time doing graphics and exploring our data, So this is really powerful for us. I don't know if you already know this package, but it's very, very useful. Just to you seeing here, I'm gonna share with you the results. I don't know, did you see the results in your screen, in your computer? So I'm gonna stop to share this one to start to share the report. It's very fast, just to you see in here. In here, we can have the types of columns, the percentage of discrete columns, continuous columns, the complete rows, the missing values. We have no missing values in here, just to you see. The structure of the data, the information of the quality of the data. So it's good because there's no missing value for each one of the columns, the distribution of each one of the features that we have, and the same for the frequency of each one of the features, and the quick plots. So we have some one in here that are not like numerical data, so are this class data. So because of this is weird, and we have correlation analysis and PCA analysis as well. So with this information, we can take some decisions without spend a lot of time. So I'm gonna stop here again and start with the other parts. Okay. So the guys put, they have the class 1 as the presence of heart disease. And the values were 1, 2, 3, 4. And they put all the things that are higher than 1 and then 0 as 1, the class 1. And the others, the value 0 is the absence of heart disease. And this is class 0, Can you understand this? It's fine? I think yes.
Yes.
So we have two classes. The class 0, that's the negative one. And the positive one is the class 1. So they put all the values higher than 0 as 1. Just to summarize the data, we have here the minimum value, the maximum value, and the criteria. It's a way to explore the values of your data as well. Just to see the class of each one of the features. So they just numeric, all of them, most of them are with numeric, and we have some of them as character. And it's because we have some values in here that's not right, and we have to change this because machine learning cannot read character features, type character. This is just to transform the data. So age was as integer, sex as factor, because if you will not put as factor, they will think that 0 is best than 1, and it's not. The values is the same for both, for the prediction. The same for factor, so for CP and so on. So that's a way to show you that it's important to transform your data in the appropriate way to your model be able to understand really the value of this feature in the model. Again, we can see this, do the supply to see the class of each one of the features, summarize the data again to see the distribution of each one of the features. This is just to show you guys that we have, the most of time, we are confirming if our features in the right formats. And in this data set, we have some interrogation signs. I don't know if it's like this in English, but we have some, and that means that they are understand as NA, but does not understand the sign question mark. Yeah, thank you. So we have to replace as NA. So just replace as NA, see if you have some NAs in the data, and you have in TI and CA. So they took some decisions to process this data. They consider the NA in the TI as 3, that is considered normal. These kind of decisions we have to take. We have to make these kind of decisions during our process as well. But they are just explaining, we consider in here as normal, and we replace all the NAs in here, and now we have only TI. And for TI, they did the same. They process to remove. And now I will create again a new report, but just to see the distribution of the data now with this transformation. And I will stop to share again because I think you cannot see my screen. Let me see.
Patrícia, in general, the transformation was just transforming the data in a factor.
Sometimes, yes. It depends of the type of feature that you have. For example, if your data is a discrete class, 0 or 1, it's a factor, the kind of transformation that you have to do. But sometimes you can just discretize the class. You have values 0 for some, 100, 100. And you have to split in 4 parts. So 0 to 25 will be 1, and 25 to 50 will gonna be 2, and so on. This is a other type of transformation. The same when you have categorical class, like married or single, and you have to transform in 0 or 1. It's a other type of transformation that is named the hot encoding.
So if I am working with expression data and my data is expression values of microwave or Buck-RNA-seq,
If you have
what I need to transform this data? Because I have if I am working with the round counts, I have 0 to 10,000 or more. I don't know.
Yeah. If you have the same type of data, your life is easier because it's all in the same proportion. So you have to do only or a log transformation or a z-score transformation in your data. But for example, you have the expression data. So it's all numerical data. So you have no problems with transforming variables. But so if you have you want to put age as a feature, you should transform your age variable. No, so we do this with this score transformation. If you want to put some demographic data in your data set, the same. If you want to put information about the sex, the same. You have to make it as a factor. No, it will depend. But the problem with do not transform the data is when you are putting information that's not comparable, because the model cannot understand if the information is really what the model is reading and learning. Because of this, we have to make this process easier for the machine.
And Patricia, how do you know what kind of data you have to transform? Because, for example, you know that age you have to transform on this. Expression data you have to transform. How do you know this? Is like practicing?
Practice.
Okay.
But I think if you do some feature engineer tutorial, you can understand what's important to know, because you have to like when we are programming that we have to like feel as the computer is understanding our instructions. Is the same, because you have to understand if I put this as a continuous data, but it's not, my model will understand it wrong, my data, and I have to make sure that my model is understanding closer as possible the data that I have. But this is experience, because it's gonna be practicing, I think, to understand this. But remember, if you have a categorical class, you have character data, we will be not able, I don't know how I say this, to get a prediction, because the model will not accept NAs or categorical data. And how to lead with categorical data? With encoding variables 0 and 1. How to lead with factors that are not as like class 1 and 2, that's not the value, is the category. So it's not so difficult, but you have to change your mind to try to understand this,
Okay, thanks.
You're welcome. So now we have a bit different distribution in our data here. We have more missing values in Thai. The distribution of the data changed a bit, and the same for the frequency, because now the data is in a different formats. And the quick plot is different too. The correlation in here, so always treat your data to be able to see, to help your model to learning with your data. Just to help you with visualization in here. And again, share the RStudio. So I will set, now I'm going to start with the sampling of the data. And I'm setting here a seed. So the seed is a way to make sure that we are always getting the same data, because this is random, the way that they will split the data. So this is a way to control always the same samples, because the results can change if you change the samples. So here I'm just getting 75% for training and the 25% for test. But this, as I said in the previous class, these values can change based on the quantity of data that you have. If you have less data, you cannot use a lot for test, because you need this for training. So this is a kind of decision that you can do with more experience. But make it, put in your mind, keep in mind that you have to understand if you have enough data to test, but you need some data for training too. And here is finally, the random forest model. You need the random forest function. This is the class that you want to predict for all the other features, and the data that you want to use for training. So just it's, oops, I have some problems in here, but I think it's because of the missing some data here. Let me see. Now it's okay. But you see the results, and the default of number of trees in random forest is 500, but we can change it as a new parameter. In the default for split is 3, but we can change it as well as a new parameter. In here, our error is very, very high. It's like 43% of error. And we have here a classification, but probably they are considering our data as, let me see. I don't know why it's not working, but let me see. They are considering the classes as 0, 1, 2, 3, 4. So I think I forgot to run some part of the code.
Patricia, I noted that you didn't replace the 1, 2, 3, and 4 for 1.
Yeah, I didn't. But now I think so. Because now I have 2 classes only.
When you made the summary, the maximum value of none was 4.
I see. So it was the classic mistake forget to run the codes and try to get the results in the end. Sorry guys, but this happens all the time. But now it's true. Yeah, now our error is close of 20%. It's not so bad, but it's not so good as well. But remember that this is with all features, and we can get better results if we remove the features that are not relevant for our model. Because imagine that we have some pages, consider each feature as a page. So we have some pages in the book that's not important to understand the subject. So as a student, we are just losing our time trying to understand some subject that's not relevant at all. So this is just a way to make you understand that it's important to performing a good feature selection approach to get only the most relevant features for our model. So this is after we have the model. So as you can see here, we have the confusion matrix for the class 0, 1, and the classification error for each one of the class. So if you are interested in the class 1, you have to make sure that your model is doing well with the class 1, to choose the best model or the best features. Is it okay for you guys? It's clear? Is it clear?
Yes.
Okay. And now we can perform our prediction. So this is just to use our model, training model, in our new data set. So using the class of the test set. This is just to use the prediction. So you have the values for each one of the samples. So for the sample number 3, the class is 1, and for 20 is 0, and so on. This is another way to construct a confusion matrix if you want to see the results, the predicted, and the real one. So this is 33 true negatives, 27 true positives, 7 true and false positive, and 7 false negative. The other way to construct a confusion matrix is like this. So There's several ways to do, and this is more complete because there's the confusion matrix for the reference and the predicted. We have the accuracy of this, as I said in the previous class. The accuracy is a good way to evaluate your model only if your data sets balanced. If you have the similar number of samples for the both class. For the class 1, we have similar number of samples as class 0. 1 and 0. I don't know if I said this right, but I think you understand. So we have the confidence interval for the accuracy. We have the sensitivity, the specificity for the value. So again, if you are interested in the class positive, you have to make sure that your sensitivity is higher always. And if you are interested in the class 0, you have to make sure that your specificity is doing well. You have the balance accuracy in here, and this is we have a mistake in here because they are considering the positive class as 0. But it's easy to change this. This is not a problem. Probably the first in here. Let me see. Yeah, the levels, the first level in here is 0, and this considered 0, but we can remove this, and it's not a problem. And after we have the model trained, we know the prediction, and we have here good values in the test set. That means that our test is representing our model, and our data is not only memorizing, and our data set model is not only memorizing our data, is really learning and being able to predict correctly the unseen data. Neymar test. Yeah. So just to get the importance of the features in the model, training model is really simple. Just use the function importance. So I think you will never forget this. So we have the values for importance for each one of the features in here. And we can order these features to see, just to create us a data frame, create the row names, order the features, just to construct a good data set, in here. But this is not okay. I'm considering this symptom as the name of the data set, but you can put in here the variable that you want to predict, just to make sure that you are keeping control of your files that you create with this. Create a data folder. Again, to order our data. So CP is the feature with the highest importance value in this data set in our model. Write the table, symptom not found. Oops. Agora, now the symptom will be found. Okay. So we have the values of importance for each feature. This is just a way to see the values. So we have this upload showing in here. I think you cannot see. Okay. So we have the value of importance for each one of the features in here. Another way to show this can be, let me save this, is like this, with a bar plot showing the relevance of the features and the importance value, like this, just to be easier to see the features. Tell Edson, ask.
Sorry, me again. Because this is how do you check if your machine learning analysis was good to predict something, like to predict the sex, to predict some disease, something like this?
Yeah, the confusion metrics using the test set. So in here, we perform our prediction using the test set, that's unseen
Mm-hmm.
data, like this. And with this information, we can get the confusion metrics, and we can have the information about sensitivity, specificity, the accuracy. Of course, the perfect accuracy is one, but depending of the type of data that you have, the challenge that is to predict a specific class, accuracy of 0.82 is amazing, you know. So you have to decide based on the difficulty, the challenge of your data set, and the kind of prediction that you want to do. Remember that as we are predicting biological class,
Mm-hmm.
our accuracy needs to be closest as possible as one, because we are not recommending some product. We are living and we are working with a life, you know.
So based on a lot of characteristics of a person, you are predicting if this person can be in the group disease or in the health disease.
Yes, can be. This
And
is a one way to predict first.
I remember, and you can do this prediction for one characteristic by each time you run the analysis, or you can predict a lot of things in just one step of the analysis.
Sorry, a lot of things in what?
Eu vou falar em português. Você pode predizer várias características ao mesmo tempo, tipo assim, só numa rodada de machine learning, ou você pode predizer, ou você tem que fazer, tipo, eu vou predizer se a pessoa é doente, aí faz uma rodada de análise. Eu vou predizer uma característica 2, aí tem que rodar de novo, tudo
Sim.
separado.
Cada vez que você roda, você direciona suas features para prever uma classe.
Tá.
Seria doente ou tratado, por exemplo.
Tá.
Isso é uma rodada. Aí você vai, todo o seu modelo vai ser treinado para fazer essa classificação. Poderia ser múltiplas classes. Então, poderia ser prognóstico de, sei lá, nível do tumor. Podia ser 1, 2, 3 e 4. Então, você faria uma classificação que é de múltiplas classes e conseguiria saber o nível do tumor, 1, 2 ou 3 ou 4. Só que se você quiser prever, fazer uma classificação se a pessoa é alta e se a pessoa tem qual idade, teria que ser em modelos diferentes.
Okay. And two more questions. And the second, actually, I forgot the second one. The third one is, and this graphic right now is like CP is more important to this prediction. CP, TA, CA, and something like this.
Yes.
So,
yeah, but you have to make it keep in mind that this is the value considering all the features. So
okay.
if you remove some of them, the importance value will be changed.
Mm-hmm.
And the same way you can change the order of importance, because if you remove one feature, maybe the model will try another approach to get the classification.
I remember
so the values can change.
I remember when I was talking to you about your analysis, you told me that you made a lot of analysis to find the final analysis. And how do you know when your prediction is good? Like, okay, now I can trust on this.
Yeah, I have to consider the values in here as in here.
The sensitivity, specificity.
Sensitivity, specificity. So the AUC, that's the combination of both, and the Hawk curve. I can have the idea based on the features that I have. So if the features make sense or not. But for example, if I have a classification with accuracy of 60%, I know that's not enough for a biological outcome.
Mm-hmm.
I know that's not enough to say for a person if she will have some adverse effects or some complication or protection, because it's just a bit more than the random choice.
Mm-hmm.
So the data set that you choose, the way that you propose the data sets, the features that you choose, all of this is going to change your results, your accuracy results, your sensitivity and specificity results. So it's not like different expression analysis that you compare a group with another, and all the time you have the same results.
Mm-hmm.
It's different. Because of this, it's so challenging, because you have to do this several times until you make sure that you have the best result as possible with this data. No?
Okay, thank you.
You are welcome. If you remember the second one, please let me know.
I asked it for you. What was this? Was this?
Okay. I'm so lost. Okay. So you understand the importance, the calculation of importance, just a way to see which features are contributing more, because during the randomization for construct of the decision trees, the model is learning the features that helping to get the best classification. So the features that appear more in the model, in the decision trees, are the one that's most important. But this can change, because if you don't have some of these features, you will have problems. This will be not the same, because the model will learning in a different way. So it's simple, but it's like this. And another thing that I want to show you. Pode falar, Juan.
Hey Patrícia, how are you? I was thinking about how can different algorithms, such as logistic regression, for example, can impact on the importance, this prediction of importance. How I just don't understand how these algorithms works. So
The algorithms will impact a lot, because each one of them will use different approaches to learning your data. It's like us, each one of us is a different student, and the way that we will study a subject will be different. And we have different grades in our evaluations, because we have different approaches, and some of us can have a better approach to learn the information than others. So it's the same for the algorithms. It will depend, and because of this, I always say to you to test different ones, because we have some algorithms, because the way that they are constructed, they used to be better, as the random forest, XGBoost. But some ways your data are so specific that maybe the naive bias will be better. We never know. And it's very fast to run this if you have not a big data. And you're performing a good feature selection and remove the most of no relevant features. We can have a training in a very fast way, so like some minutes. So it's not necessary to test only one algorithm. You can use this for several ones. And because of this, I will show you the carrot package. I'm gonna show the carrot as using the random forest, but it's so simple to use this for other algorithms. It's not so fast as using the original package, because carrot use the original package, so call the original package to do the analysis. And if you don't need this kind of intermediate, it's faster. But carrot is a way to evaluate all of them in the same way. So keep the data in the same format, and that's great. So just to show you very fast in here, the carrot package is for R, for machine learning analysis, but it's similar as scikit-learn for Python. or Weka, or TensorFlow, others that you have several algorithms of machine learning, and you can perform your training and your prediction in the same place for different methods. So for a run caret, you need to fit the control for your training test. So this is the function here, train control. I use in here the method cross-validation, but you can use other. It depends of your aim in the analysis, but I recommend to use the cross-validation always in the training set. Number of scaffolds, you can use like 5, but you can use 10. It will depend of the size of your data set. If you have a higher, a huge data set, 10 is better. But if you have a small one, I think 5 is the best option. This is to save the predictions. Class probability, yes, true. I put true in here. It's just to, for example, the prediction is 0 or 1. But if you want to get the value of the probability to be 1 and probability to be 0, you can assess if you put this class as true. Summary function, so to class summary, just to get ease in the metric, I choose Hawk, because we can assess the sensitivity and the specificity in the same way, in the same moment. Let me run this. Oops, sorry. Metric Hawk, set a seed again. Using the training setting here, I'm going to train the methods RF. It's the handle first. We have several others handle first methods, and depends with some variations inside the carets, but this is the traditional one. And for example, if you have to run another one, for example, ADA boost, you can put it here, ADA boost. If you want to use ADA, just put here ADA. But you have all the list of methods in caret package file with the informations. But for handle first, it's very simple, just to put RF. Don't remember to put the fit control. And this is to turn your model to find the best hyperparameters for our training. It would be great in the oops. Again, I'm having some problems here, but I don't know what is my problem. I have some thinking wrong here. Let me know if you understand what I'm doing wrong, because I'm not. Just a minute. Agora foi. Tá treinando. Ai, treinou. I don't know if you could see the difference, but it's a bit slow than use directly random first from the original package. But I think this is really useful and and compensate the time that you spend a bit more to perform your analysis, because you can compare all the data in the same way with different algorithms. So what is showing here in the model is that we have 225 samples, 13 features, 2 class, 0 and 1, cross-validation 5-fold, okay. And as we use the tiny length parameter, the model can say the best parameter is M3 try equal to. So the model will be used as using the M3 try equal to. Just you see, here is the results for Hawk curve, sensitivity, specificity, sensitivity, standard deviation, We have all of these in here. Just to explore a bit. Here you have several information. We have the methods, random forest. We have the information about the model. If you can use this is the model, so you can access all the information about it. Model type is a classification. You can do regression with random forests as well. It's not for all of the models, the algorithm that you can perform both the classification and regression, but in random forest you can. The prediction, so the values and the prediction for each one, as we put the probability yes, true. We have the probability for B class 0 and class 1. The final prediction using the n-try equal to, and for each one of the resample in the fold, the cap folds that we use it. So all the information that you need is in here. So just a way to get the best tuning without analyze the model is using this function here. So the first one, because n-try is the first one in here, so they get n-try equal to 2. And this is the prediction, the way to predict, so this model and the new data set. And this is the prediction values for each one of these samples that we have. And we can here evaluate the probability is the same. So we're using here type probability. It's not mandatory, it's just a way. If you need for some reason the probability, you can use the type equal probability. This is the construction matrix, confusion matrix again. We have the accuracy, the sensitivity, specificity. As you can see here, using this kind of randomization, our accuracy is low. And because of this, I said, Edson, that it's so important to identify the best combination of data to get the best evaluation, because it's gonna changing based on the data set that you have, the randomization of the data sets, the types of features, the way that you run. It's all impacting your results. So this is the confusion matrix. Again, the class is positive class is x0. I will change this because this is not the right way, because my positive class, as you know, is 1. But this is simple. Okay, Edson, you can talk.
Did you have the same result of prediction from the two methods? Like you made your code using random forest and etc. And in the last you made random forest also, but with another pack. Did you have the same result?
Yeah, if I use the same seed, probably yes, very similar, but not exactly the same, because it will depend. The algorithm is trying to learning, and depends of the way that you randomize your samples, the results can change.
So if I run the same code many times, probably I will have different results every time I run.
If you set the seed, no. But if you do not set the seed, yes.
In general, the answer will be the same, but the numbers of specificity, sensitivity will change a little bit.
A little bit can change. Okay. This is normal, but not like all the results or change a lot your results. It's not like this.
It's
in general,
like,
it's close. For example, you will not. I use different data sets, like randomization of the data set for use this different packages, but it's similar. The value is not very different. We have a sensitivity and specificity. It's very close. For the others, accuracy that's a bit slow, but it's not so slow. No, but probably if I use the same seed for both, the value will be closer. But sometimes it's not the same, because it will depend.
It's like a clusterization. Usually you have the same result, but the numbers are different, a little bit different.
Yeah, exactly.
Okay.
It's exactly like this. It's not, and be okay with this is normal, because in the start, when I started to working with machine learning, I was so upset with this, and I was like, why this is not right? It's not correct, but it's like this. It's always like this. It's not a problem, you know. And we have to make ways to lead and choose the best approach and the best set of features. I don't know if you understood this, if you have any doubts about the method, but with this code, you can start from zero. Of course, I think you can change if using your data sets, and it will be not difficult to run at all. It will be really okay for you guys.
I think it's a little bit complex than the explanation in the last class. In the practice is a little bit complex, but I think was a good first contact. It will help us a lot. But I think for me, I need some time to spend the time on this to understand better. But I, I'm not in the fog anymore.
Yeah, so I think what is important, if you have start with a expression data, because if you have the same kind of data for all of our data, you have less work in the start. So make sure that your data is split in training, in test sets, and after this we perform the normalization, or with z-score or log transformation. Because if you transform everything together, probably you have some I don't know how to say this in English, but it's vazamento de dados. When you put some information in the test set that is not to be in there, you know, some information from your training set in the test set. So this is the start. Get to your expression metrics and do it. Defining your classification class. What do you want to classify? If the person is infected or not, if the person has specific, it's male or female, all of these you can use as a classification. You have this, you can just process your data in training tests, and with this you can run all this code, and it will be not difficult at all. So this is a way to run the random forest and get the importance of features that is important. So you can use it only for feature selection. So forget the part of prediction. No, you don't need this if you want only to see the importance of the features and maybe select just some genes besides to use the 20,000 of the genes that you have in your expression set. So I think for all of you, the feature selection using random forest will be great. So imagine that you need only this part of the coding here. This one, so this part you can comment, but it's always good to see if your prediction is doing well. And after you have the values of the importance for your features in here. You can select some of them and run again and see if your performance improved or not with the changes in the features. It's clear, or it's like I'm confusing you more than before?
Parte, I have a doubt.
Okay.
What is the smaller number that you need to do?
To do the analysis?
Yeah, in the dataset training and other dataset.
It depends. But for example, if you have you should have at least 10, but this is super small, at least 10 samples in the test set. And you have to, the ideal is to have at least 5 in each one of them, 5 to the class 0 and 5 to the class 1, because the impact of the randomization will be not so like heavy in your data, if you have at least 10. But 10 is very almost nothing. No.
Okay.
But you know that in biological data we have not a lot of samples to use, and you have problems with this all the time.
Yes, because I have a good data set from my PhD. I have 50 samples, I think,
50 samples. I think it's enough, Vivi.
Yes.
40 of them you can use for training and 10 for tests. But if this is difficult, you can use all of this data as training set, and the classification will the evaluation of the classification will be done with the cross validation in the training set. This is our option too.
Okay.
Yeah,
Thank
and you can get the importance of the features. So this is great. It's not a real classification, it's not a predictive model, but you can evaluate this. The features.
Yes, I did the evaluation using statistical tools,
Yeah.
Regressão linear, regressão logística. I used a lot of logistic regression because I have categorical and numerical data. And I think that this approach is very good for my analysis.
Yes, of course, yes.
Thank you, Mauro.
Vamos cantar parabéns?
Obrigada.
Parabéns pra você.
Essa data.
A colega.
Muitos anos de vida. Viva
Parabéns!
Você é malandro, agora que eu percebi.
Obrigada, gente. Obrigada. Dia de alegria.
Oh, gente, if you have any question about machine learning for our data, please let me know. I can help you. Okay, Yuvika, you can talk.
Yes. First thing, I wanted to know, other than you and Nicolau, who else is doing this kind of analysis?
Leandro.
Leandro and?
I don't know if he, Denei and Juan.
Okay,
But
so machine learning with biological
with a complete different
approach.
The goal is different.
Goal is
I
different.
think for in the case of Denei and Juan, the things are easier because they are using simulated data with a lot of data. So for machine learning, as much data you have, better. No.
Okay.
And as we are using expression data in most of time, you have not a lot of data, so our values of prediction will not
be different. So you and Nicolau is only doing basically this expression data.
With expression data, yes.
Yes. Okay. And second question is, someday Heather send me our package for biological machine learning for biological samples, something like that, and meta something. Can you help me remember that package?
I remember that you told me about this, but I don't remember the name of the package. But it's two cross produced from different packages. It's not like this.
No. It was a single package actually.
Yeah, but I think he.
If you got to remember this package, please let me know. Okay.
Yeah. Mauro is working for image. Yeah. But it's not with expression data. It's with image data.
Yeah.
But the process is the same. The start is very difficult because Mauro needs to extract the features, and we already have the feature extracted.
And third question, once I remember now, is there any learning, machine learning is we have to know Python? Is that?
No, it's not exactly you should know, but sometimes Python will be easier because you have it's like carrots. You have all the machine learning models, algorithms in the same place as scikit-learn and Weka, and it's not necessary to have all the packages.
Okay.
And the most of things in machine learning, as we have more users in Python, in general, the things happen faster in Python than R.
Okay, so
The
it is
evolution in
good.
Python is faster.
Okay, so you are saying that Python is good, but what we can manage with R also.
Yeah, we can do everything in R. There's
Okay.
not a problem with this at all. But the community of machine learning in Python is stronger than in R.
Mhm. Okay.
So you can do this, but in general, as I can read Python well,
Mhm.
I use Python to make some to study some approaches, and I can translate for R without any
Okay.
problems.
Okay.
But it's not a problem. You can use this code, and will be very helpful for your analysis in the start, and after you can. Oh, but now I want to see with the other algorithm. But now I want to change a bit, and you can do whatever you want.
Okay. Thank you.
You're welcome.
In our case, in about me and the Nate that you talked.
Juan, it's very slow for me. Oh, slow, no, low. You can talk louder.
Now is okay.
Yeah, it's better.
So in my case in the Nate, we performed the random forest and logistic regression, but I just did it once. The Nate that did all this part, and I'm not an expert in this.
But
So,
I think the start is a bit difficult because you have no idea about how to start. But this is a way to start.
yes, of course.
Now
So,
you are experts. Well, now we have all the tools for be an expert.
you.
But for start with machine learning, you need to have motivation.
Yes,
If in your project you have no way to use machine learning,
Now I
it's
am
not.
having
I just did it
motivation.
Yeah.
from this. I understood why we use two methods, but in the algorithm, that was the question that I made that I did. What is the difference in the algorithms? But this is more complex than I.
The way that the algorithm is constructed. Basically, the algorithm of machine learning is a lot of if. But the way that the algorithm is constructed will depend. Some of them use the try to produce the dimensional of data and set a line to replace them. The random forest uses the data set randomly to create decision trees. The others is the boost types is they use different algorithms one by one. So the samples that one algorithm get wrong, the other one correct. So it's not so difficult to understand, but I think for now it's not the important part. The important part is to know how to use the data in the proper way and what class you want to classify.
Okay. Thank you.
You are welcome. If you need anything, please let me know.
Okay. I was thinking about just one more thing. I was thinking about like an experiment, but I don't know if it is useful, because let's say that we have this graph of importance that you have on your screen. So let's say that for this feature that you classified, you want to test the sex for each of the variables. Uh, can we split our data set in male and female and classify separately, and then check the difference of importance of CP, for example? Uh, the same data set is the same data set, but split it for sex. So we will have a value for CP 14, and for male, and for female we will have 10. And the same thing for the other features. So how is this useful, since we have the importance of sex plotted here?
That's a great question. Well, I think it's a smart way to think. Yeah, the importance will be different, of course, because the data set is different. But it's a way to evaluate, because the only thing that will change is the female or male information. So I think we can evaluate, but make sure that we have all the features in the same way. And if you have the same number of samples for each one of the group, this is gonna be better than only, for example, 10 male and 100 female. This will be unfair. So just to keep it in mind, but it's a way to evaluate the impact of gender in this. Another way to evaluate the impact of the gender is to consider gender as a feature. And evaluate the importance of the gender as a feature in this data set, because it will be very different in comparison with different data sets. So if for example, this one, for age, the value is 10 of importance, but for other data set, the values will be different. It's not the same always.
Yes, that was my concern, because we have sex there, like 4, almost 4, and so for that's the concern. And for different different data sets, these values will be different.
Yeah,
So-
because the samples are different, and the model is doing nothing more than learning with your data. So the results will be very dependent of your data more than your model. The model is the algorithm is just a way to adapt to the kind of the data that you have, but it's a way to learn.
Okay.
So it's weird, but I think all of you can understand that it depends of the samples more than for other classes.
Okay. Thank you.
Yuvika send a link. Send a link.
Is this the same link,
Yeah.
right?
MLSec. Yeah, right. This one. Oh, guys, it's great because all the code is here and everything is very easy to understand, and we can control the values, the prediction, and all of these using
It's the
this
same
package.
thing I told you, right? It was the same link, right? Okay.
Yeah. Okay, I think we can finish. If you have any questions, let me know. Any more questions?
Thanks, Patricia, for doing it in English. It was great.
You are welcome. Sorry, guys. It's Yuvika's fault.